Okay, y'all can see that. Okay, so let's sketch a hyperbola really quick. I'm going to sketch it crudely, and then I'm going to show you a detailed picture of all the parts of a hyperbola. Okay, so let me pull out my desk here. So just like an ellipse has 4 points, right? Sorry, somebody's calling me. An ellipse has 4 points. A hyperbola also has 4 points. But instead of drawing an ellipse through all of these guys, we're going to draw a box around these points. A hyperbola can either open to the sides or up. And make these a different color so this is clear. Whether the box is longer in terms of width or height does not change which way it opens. We'll talk about what changes which way it opens. For now, I'm just going to draw, I guess, a horizontal. And so these are this. So then here's going to be a focus, just like an ellipse. Here's going to be another focus. And this is a vertex. I'll do that in the same color. Also a vertex, and we call these the co-vertices. And so the hyperbola will come through, and also, I guess, so let's has this symmetric attitude. And furthermore, I can illustrate something interesting that happens. And here's the center of the hyperbola, right? Just halfway between the vertices, or halfway between the co-vertices. This line, the hyperbola does not pass. We call this an asymptote. It's like a barrier. And in fact, as this goes off to infinity, it's going to get closer and closer to that line, and the slope of the hyperbola is going to get closer and closer to the slope of that line. So this is a horizontal hyperbola. The vertices are where it touch. The co-vertices are the opposite axis. The focus is with the vertices, that same axis. Do you have a question, Braden? Because it says you're typing. What is the white line again? This is an asymptote. Yeah, that's a good question, Braden. And so let me go to my detailed picture. I just wanted to show you how to sketch one before I just bombard you with this. Okay, so don't panic yet. I just wanted to do this all ahead of time so I could explain it instead of spending a lot of time drawing it. So here, these are the co-vertices. I didn't even label them, so let's label them. The vertices lie in the same direction that the hyperbola is opening. These are the asymptotes in pink. The co-vertices are in the opposite axis. The co-vertices and the vertices make this box, and the box dictates the slope of the line, and the slope of the line dictates how wide or thin the hyperbola is. So as the co-vertices increase or decrease, it's going to change the width of the hyperbola. Yeah, it is, Liam. Are you on the app on your laptop? Maybe try giving it a restart or closing out of the app. That's kind of crazy. But yes, it's being recorded. So the focal distance is still C. We no longer have major and minor axes. Instead, it's a transverse and conjugate axis. The transverse axis runs in the direction that it opens. Here I have it in red, and it's still 2A units, and it has the vertices. So the transverse axis has the vertices. Conjugate axis runs in the opposite direction, and its length is 2B. Notice the conjugate axis is actually even longer than the transverse axis right now. This relationship does not affect the shape. So notice I actually have over here, in white is a horizontal hyperbola, x minus h squared over a squared minus y minus k squared over b squared, just like ellipse, but the sign is different. In the vertical hyperbola, so notice currently x is positive, y is negative, and you switch them. So depending on what's negative, not depending on what's bigger, that was for ellipses, but depending on what's negative is the direction, what's negative or positive. So the positive one is the direction it's in. So positive x, so x direction, and positive y, so y direction. So I would take a moment to copy all of this down, and I give you guys 4 or 5 minutes so you can copy this down. It's important that you draw it yourself as well. And if you have any questions, write them down, let me know, ask them in the chat. And now we have a different formula. It used to be a squared equals b squared plus c squared, but now it's c squared equals a squared plus b squared. C, the focal length, is now the largest number of the three. Oh, I'll give you a picture, Liam. You can see but not hear. That's strange. Check your, well, I don't know why I would be talking to him if he can't hear. So take a moment to copy this down, y'all. It's important that you draw it yourself. And here are the formulas. These are also important. Over here on the left. Also, I didn't mention earlier, but the slope of these asymptotes is b over a. Well, that makes sense because they go through these corners. And to get from the center to the corner, you have to go b units up and a units over. It's literally just rise over run. So the ratio between a and b dictates how wide the parabola is. Hyperbola. Jeez. And just like for an ellipse, the foci were always on the major axis, the foci are always on the transverse axis. They have to be inside the curve. Notice here in yellow. When you finish copying this down, please let me know so I can know when most people are pretty much done and we can continue. Cable's donezo. Anybody else finished? Or any questions about the hyperbola before we get into some problems? Thank you, Dylan. Does it matter which one we copy? Horizontal. So this big one is a horizontal hyperbola. Vertical is just like everything is rotated. So I have a tiny little sketch of a vertical hyperbola right here, but this big guy is horizontal. It doesn't matter which one you copy down, basically, as long as you label the vertices, co-vertices, and whatnot. Thanks, Kev. Does anybody need more time? If you need more time, please let me know. Are we all pretty comfortable that we understand the anatomy of a hyperbola here? Nice. Good, Liam. B and A have no relationship. B could be bigger, A could be bigger, it doesn't matter. And the relationship between B and A for ellipse would dictate the orientation, but no longer. The hyperbola doesn't care. The hyperbola only cares whether the x or the y is positive. But in this example, B is bigger, but it doesn't have to be bigger. So Liam, now that you're just seeing this, do you have any questions about this? What does C mean? It's focus, just like ellipse. For a similar reason, and we're gonna actually talk about how a hyperbola is defined. Does that make sense, Davis? Let's move on to the definition of a hyperbola. So for an ellipse, if you took the distance from any point to both foci and then you added those distances, is a constant number. Now the way this works is if you take the distance from any point on the hyperbola and you find the two distances separately to each foci, the length of these legs are always going to differ by 2a units. So we have like this double absolute value stuff. This is kind of hard to look at, right? But all this means is the legs always differ in length by the same amount. So if I pick another point on the hyperbola and I draw to focus 1 and to focus 2, these legs differ by the same amount as the other ones did. Or here, even, to focus 1 and focus 2, those legs differ by the same amount. So you convert each distance into a length, find the difference. So this is the magnitude difference between the magnitudes. Okay. So let us try an example to write an equation giving vertices and foci. And so it's going to be all the same, except we have a couple things here. So orientation we have to determine, and that will tell us whether x or y is positive. So we have to determine the orientation. We need A and B still. C would help. C would help us get A and B, and the equation is c squared equals a squared plus b squared. And then we need the center, just like always. So I'm going to sketch this 2, 6 and 2, 10. So if I have 2, 6, 2, 10 would be 4 units above it. Meaning the center would be at 2, 8. Just like the ellipse, the center is directly between the vertices or the co-vertices. And since these are the vertices, it tells us that the orientation is vertical. So I'm just going to do a really rough sketch. So now we just have to find A and B. So A is the vertex. It's the distance from the vertex to the center. So that would be 2 units. A equals 2 units. And B is the distance from the co-vertex to the center. And we don't know that yet. We're going to have to find that using this Pythagorean formula. So c squared equals a squared plus b squared, and we do have c. I'm just going to draw these foci. One focus is at 2, 4, that's the bottom one. And the other focus is at 2, 12, that's the top one. So that means c is 12 minus 8, 4 units. Notice this yellow dot is 4 units away from the gray dot. So c is 4 units. So c squared equals a squared plus b squared. So 4 squared equals 2 squared plus b squared. So 16 equals 4 plus b squared. So b squared is 12. So now we're ready to write the equation. I didn't give myself a whole lot of room here. I'm going to write it over here in pink. So it's vertical, so the y is positive. So we have y minus the y coordinate of the center, that's 8, squared over the positive fraction gets a. So a is 2 minus x minus 2 squared, the x coordinate of the center, divide by the negative fraction gets b. So b squared is 12. Sorry, a squared is 4, right? And so here's our equation. Any questions? We're good with this? Thankfully, all of this is really close to exactly how the ellipse goes. Ellipses go. So here's a board work I would like you to try. In fact, I'll leave this up here. So you're given 2 vertices and 1 focus. Please go ahead and write the equation. And let me know when you're done. Thank you, Cable. Thanks, Dylan. And here also, I'll show you guys again. So I change my, let's see, change windows. Oh, come on. Okay, we'll just not do it. Desmos doesn't want to do it. But I can, let's see. What we can do is, oh, that neither. Okay, I'm going to assume most of us are done with this, so let's take a look at the solution. So, vertices are at 5, 3, 7, 3. So, they're going to be vertically changing. Meaning that the center is at 6, 3. And if these are the vertices, that means that the hyperbola goes straight through these. So it must be vertically oriented. Oh, sorry. I'm completely rotated, am I not? So, let's be careful. Five, 3, 1, 2, 3, 4, 5, and 7, 3, 1, 2. Here are my vertices. My center is in between them at 6, 3. The hyperbola is going through the vertices. So we have a horizontal guy here. And we have a focus is at 10, 3. So the focal distance C must be 4. A is the distance to the vertices, which is 1. So C squared equals B squared plus A squared. So C squared equals, 16 equals B squared plus 1. So B squared must be 15. We have everything we need now. So I will write the equation here off to the side. So it's horizontal, so that means x is positive, and a goes with x. So we have x minus 6 squared divided by a squared. So that is 1. Wait, b is 1, and a is 15. A squared is 15. No, I was correct. Sorry for the confusion, y'all. B squared equals 15. So over 1 minus y minus 3 squared over b squared, so 15 equals 1. And I'll explain why it is this way. Notice here on the bottom of the x fraction it tells us how far the vertices are in that direction, just 1 unit away. In the other direction, they'll be root 15 units away. Any questions about this here? Did we get that? All right, let's take a look at another one. Okay, so we have some information here. Asymptotes have slope plus or minus 5/7. We have the location of two covertices, and the question here, I'll circle it, is to find the equation and to locate the foci. And this is a class example, so I'll walk you through this. So let's draw a sketch of what we have. -3, -6, and -3, 4 are the covertices. So the center will be directly between them. That's -3, -1. I just average 4 and -6 to get -1. So the center is -3 and -1. And we only have another piece of information, right? Is that the asymptote slope is 5/7. So whatever the shape of this box is, the box better be in proportion of height to width 7/5, or in proportion of, height to width 5/7, right? And so that makes sense because this is already 5 units. So that means this has to be 7 units. Rise over run. So this tells us that these vertices are 7 units this way, and my box is hilariously out of proportion. So I'll just erase my axis. And so 7 units to the right of -3 would be 4, -1. And 7 units to the left, we actually don't even need it. So we have everything we need, right? And those are the vertices. So let's draw our hyperbola. So here A equals 7, B equals 5. It's horizontally oriented, so X will be the positive one. So we get X plus 3 over 49 minus Y plus 1 divided by 25 equals 1. Questions? Alright, I would like y'all to take just a 2-minute break. So be back at 2:45 and we'll finish out. Make sure to stretch your legs, get a snack. Do some one-arm pull-ups. No worries. What do you mean test? Yeah, that's my question, Davis. We're going to continue to have weekly quizzes over the topics we cover. Um, there's there. Uh, I haven't decided what I want to do towards the end of the year. We're not going to have a final like you've had them before, but it will be a perfectly reasonable short assignment. I haven't really decided what I'm going to do yet, but you don't have to worry about it. It'll be easy money. That's true, Davis. It's the 5G towers. Alright, go ahead and attempt this practice problem, y'all. How much more of the lecture? Just one more board work after this. I did say that, and I regret that, and I apologize. Sometimes I drastically under or overestimate how much time students need. But whatever I give you is going to be 30 times easier than having a cumulative final. I don't even believe in cumulative finals anyway. Are y'all done? Still working? I assume most folks are done. So this gives us A equals 4. C is 6. So here's a focus. Looks something like that. So C squared equals A squared plus B squared. 36 equals 16 plus b squared, so b squared is 20. So we get, it's horizontal, so x is positive. Whoops, this should be shifted over. I just won't draw the other half. We just have the left half of our hyperbola. It's fine, it's perfectly symmetric, so we know what the other one looks like. So we have x plus 3 squared gets a, since that's the orientation, so a squared is 16, minus y minus 5 squared. It gets b, because it's the conjugate axis, 20. Any questions? And lastly, I would like you to do this problem. It's just like before, just slightly different. You'll see. Just complete those squares. Have you finished? Please let me know. Let's take a look. Thank you, Dylan. I appreciate it. Otherwise, we'd probably be sitting here all day. 25 lots of x squared minus 4x minus, so this is different now. This is why it's a hyperbola and not an ellipse. 4 lots of y squared minus 12y equals 144. So if I want to complete this square here, I got to add in a 4. So I just created 100 units. So I got to add 100. And then to complete the square over here, I want to add 36. So I just created negative 144 units. So I need to subtract 144 units. So these actually cross out. So I am left with 25 lots of x minus 2 squared minus 4 lots y minus 6 squared equals 100. Finally divide everything by 100, so this becomes 1/4 x squared, x minus 2 squared, divide by 4, minus 1/25 y minus 6 squared. Just like before. Very easy. Any questions about hyperbolas? Anything like that? And that's the last conic, believe it or not. There's not some secret lurking conic shape. Okay. So thank you so much. Have a great day, y'all. And let me know if you have any questions.